Hi dear students, in this presentation we will be discussing about biochemical conversion of the biomass. Biochemical conversion involves the use of enzymes of bacteria or other microorganisms to break down the biomass through the process of anaerobic digestion, fermentation or composting. So here we are utilizing the biological methods. The biomass is converted, the more moisture content biomass is converted into uh, fuels by the action of the small organisms called the bacteria. Okay, the biomass can be turned into different products such as hydrogen, biogas, ethanol, acetone, butanol, organic acids, etc. by selecting different microorganisms. See what should be our end product. Based on that we will be choosing the microorganism in the process of biochemical conversion. So based on how which organism is being selected, the end product also varies. Mainly the popular one is biogas. We will be producing CH4 methane as the main component by this process. Compared with other conversion technologies, biochemical conversion technologies are moderate, pure, clean and efficient. So this is gaining more popularity compared to the other mechanisms. See here, not much energy input is required as in the case of thermochemical conversions. Here just we are allowing microorganisms to act upon the more moisture content or slurry type biomass that we are providing, but due to the action of the bacteria, the biomass is completely converted into its gaseous or liquid form that is being used as the fuel. Mostly in the gaseous form it is being produced. So we are providing some favorable condition for the action of the enzymes of bacteria. Usually two types are there. Either we will be doing it in the anaerobic conditions. So in that condition, anaerobic is some type of bacteria which will be in action on the absence of the air or oxygen. So that is most popular one. And of course in fermentation and composting we will be going for the biochemical conversion in the presence of the air. Of course the last one, that is composting, we are not getting any fuel as output. Instead we will be getting fertilizers only, so that is not being used for the production of the fuel. The other two are the popular one, that is anaerobic digestion as well as fermentation. Both methods are used for the production of the fuel by using biochemical conversion. Okay, composting is just to convert the biomass into useful fertilizers. The end product is only fertilizers only we will be getting as the end product. We won't get any fuel. Compared with other conversion technologies, biomass chemical conversion technologies are moderate, pure, clean and efficient. The most useful biomass appears to be animal manure, algae, plant residue and other organic waste. These are all the commonly used biomass for producing energy by using biochemical conversion methods. And why we choose all these things are, all these biomass is having high moisture content. As I have already told, we are supplying biomass along with the water into the conversion chamber, or we can say we will be providing the biomass input in the slurry form. Okay, that is the complete it is initially completely mixed with moisture before providing into the biochemical conversion chambers. The biochemical conversion can take two pathways, that is, and one is anaerobic digestion and fermentation. So by these two methods we can produce fuel from biomass. First one is anaerobic digestion. Anaerobe is a microorganism that can live and grow without air or oxygen. So anaerobic digestion means the digestion without in the absence of the air by the bacteria. That is the meaning of anaerobic digestion. So biomass is completely digestion means it is a decomposition process. So completely decomposed in the absence of the air by the anaerobes or bacteria. Anaerobic digestion is the bacterial decomposition of organic matter biomass in the absence of the air or oxygen to ultimately produce a gaseous mixture called biogas. Biogas, the major component of the biogas is methane, comprising methane, carbon dioxide and small quantities of other gas such as hydrogen sulfide. So this is one disadvantage of biogas, that is hydrogen sulfide is there. So on combustion this will have some difficulty. നമ്മൾ സ്റ്റൗവിനും കാര്യത്തിനൊക്കെ അതിന് ഈ ഹൈഡ്രജൻ സൾഫൈഡിൻ്റെ കണ്ടൻറ്റ് പെട്ടെന്ന് ബാധിക്കാനുള്ള ചാൻസസ് ഉണ്ട്. ഓക്കെ, so that is the difficulty. Anyway, the major constituent of the biogas is methane, CH4, and of course along with methane, after the anaerobic action we will have the carbon dioxide also. This is not a combustible fuel, but still we will be obtaining it as the byproduct. So actually I missed one chemical reaction here that I will provide you while sharing the slides. The chemical reaction was decaying wet biomass around 20 to 55 degrees Celsius, that is the prevailing temperature. By anaerobic digestion will give you biogas. Biogas means CH4 plus CO2, that is the composition. So that was the chemical reaction. Left side of the reaction we have decaying slurry biomass, decaying wet biomass by the process of anaerobic digestion. In the top of that equation line we have 20 to 50 degrees Celsius, that is the prevailing temperature range, and the final product is biogas CH4 plus CO2. Now normal combusting is an aerobic process. The same thing is, whatever thing is happening in the anaerobic digestion, in normal combusting also almost same thing is happening, but only difference is combusting is in the presence of oxygen or air. So it is an aerobic process resulting in the formation of nutrient rich fertilizer and CO2, but not methane. See, once the condition is changed, that is from the aerobic process to anaerobic process, the end product is changing along with CO2. In the anaerobic process or anaerobic digestion we will be obtaining methane, which is the major constituent of the biogas. So the temperature also is to be taken care of. It is within the normal temperature range, that is 20 to 50 degrees Celsius. If the temperature increases more than 50 degrees Celsius, the end product also will be different. We won't get the biogas. So in our conditions and all, this is the one of the best method to produce the biofuel. The reaction is slightly exothermic and the heat generator helps to maintain the favorable temperature. See, during this anaerobic digestion process, it is exothermic process and some heat is released. That heat is being utilized to maintain the temperature within the 20 to 50 degree temperature range. Okay, that's all about anaerobic digestion. Now coming to the next process, that is fermentation. This method will be very much familiar to you. Fermentation is the use of ferments such as yeast, bacteria and enzymes, etc. to convert carbohydrates into alcohol, mostly ethanol, also called bioethanol. So by doing the fermentation process, finally we will be producing bioethanol. In this process what we will do is we will be adding ferments such as yeast, bacteria, enzymes, etc. For fastening the chemical reaction, or this yeast, bacteria, enzymes, etc. will act as a catalyst, we can say. You might have this process is very much familiar to you. From the sugar, starch and all, we will be producing the alcohol. That is a old age technology. So the same thing we are using here also. See that alcohol, which is ethanol, among the alcohol, ethanol is a good fuel and it is having good combustion property, everything. So by the fermentation we will be finally producing ethanol, which is commonly known as bioethanol and is used as a very good fuel. So here the biomass should have very much starch or sugar content, then only we can use it as a then only we will get the ethanol as the end product. So we have to make sure that the input biomass must have a very high starch or sugar content, then only this is practically possible. Starch and sugar based biomass such as grains and sugar crops are converted by fermentation into ethanol. So finally by the bacterial action we will be converting starch and sugar based biomass into ethanol, that is C2H5OH. The most commonly used feedstock is sugarcane, and other feedstocks include starch rich sugar beet, carbohydrate rich potato and maize. So from all these biomass we can produce ethanol. So the chemical reaction is as shown below. C2H12O6, that is glucose. That is, if it is having very much sugar content, then the glucose content also will be more. Around 60% will be glucose in the biomass that is being converted into methanol by the fermentation process. The prevailing temperature, or we have to maintain a constant temperature of around 32 degrees Celsius. That is also to be taken care of. So this is happening in the almost in the room temperature, and of course in the presence of the air. So there is not much care for this one to produce. So just by normal action itself we can produce the ethanol. നമ്മൾ പണ്ട് കാലങ്ങളിലൊക്കെ വാറ്റൊക്കെ ഉണ്ടാക്കിയെടുക്കുന്നില്ലേ, ദാറ്റ് ഈസ് നത്തിങ് ബട്ട് എത്തനോൾ. ഓക്കെ, so it is a alcohol, so it will readily burn. That is the advantage. Same process we are using here also. Just to fasten the process, or as a catalyst we are adding yeast, bacteria and enzymes. പണ്ട് മോര് പുളിപ്പിച്ചിട്ട് തൈരാക്കുന്ന പരിപാടി, പാല് പുളിപ്പിച്ചിട്ട് മോരാക്കുന്നില്ല, അതും ഓൾമോസ്റ്റ് ഫെർമെൻറ്റേഷൻ പ്രോസസ്സാണ്. സോ വി ആർ ആഡിങ് some kind of yeast to convert milk into that one. Okay, so now coming to the anaerobic digestion processes, we are commonly using two types of digesters. One is fixed dome type digester and the other one is floating drum type digester. So sometimes question may come from this portion also. So I will explain first one, fixed dome type digester. This is a digester commonly used for anaerobic digestion and to produce the biogas. Okay, so you can see in the figure it is having a fixed dome. This is the dome, this is fixed one, and of course we will have a slurry inlet tank here. Here we will be providing the biomass in the slurry form as an input. So based on the chemical reaction or decomposition happening inside this fixed dome, the slurry inlet that we are providing here will be gradually moving downward due to gravity, and it will be entering in the bottommost portion. So at bottom portion we will have the fresh slurry that we have provided in the slurry inlet tank, and the decomposed, already digested or decomposed slurry will be in the topper portion. So this will be in the almost liquid form after decomposition, or the thick fluid after decomposition, but here we will have the solid suspension also. This is the pure slurry that we are providing at the inlet. At the uppermost portion we will have a thick fluid like composition after digestion. ഒരു കുഴമ്പ് രൂപത്തിലൊക്കെ ആയിരിക്കും, ചളി പോലെയാണ് ഇവിടെ ഉണ്ടാവുക. സോ since it is in the liquid form, the level of the liquid will be always same everywhere. Here as well as here we will have the same level of slurry. So finally what happens is, after digestion the slurry we will collect it through this outlet tank. From here we can have the slurry collection, which can be used as a good fertilizer. So at the we are providing slurry as input to the fixed dome digester, and finally we will get the sludge is collected at the outlet tank. So the reaction, anaerobic reaction, is completely taking place within this fixed dome area. So the gases produced by the anaerobic digestion, that is methane, will be collected at the top of this region. Since this is fixed one, dome is fixed one, as the biogas content increases here, what happens is the pressure inside this chamber will be increasing. So once this will have this increased pressure will push the sludge at the top level towards the bottom side. So if the level of the gas within this region increases to a particular limit, what happens is there is a possibility that the biogas produced will escape through this outlet tank also. So before it is escaped through the outlet tank, we have to continuously collect it. That is the main difficulty as far as fixed dome type digester is concerned. Okay, the pressure inside the digester increases as the biogas is liberated. So once the biogas liberated gets accumulated, once the biogas liberated gets accumulated in this region, so pressure in this region will be increasing. So the biogas get collected in the upper portion of the digester in a dome shaped cavity. The outlet pipe is provided at the top of the fixed dome to collect the biogas produced. See, here we will have the collecting pipe, so it will have some valve also. During the reaction and all, the valve will be closed once the required pressure reaches, or once the capacity of the biogas produced in this region reaches the maximum, so valve is opened and it is collected. We have to use it at that time itself. The main difficulty with this type of technologies are, we don't have storing technologies for the biogas produced. So if you want to store it in a separate chamber, means we have to convert it into liquid form. That chemical transition from gaseous form to liquid form, or liquefaction of the biogas or methane, is very costly, so it is not practically possible, or alternatively we have to find out some other options. The fixed dome type digester can be fed on daily basis with small quantities of the slurry. The excess slurry in the digester gets accommodated in the displacement chamber. Here, this is the displacement chamber. This portion is the displacement chamber. So, extra slurry after the anaerobic digestion or sludge will be getting collected in this way. Of course, here also we will have the sludge, and here also it is completely always the liquid level will be same everywhere. So, whatever sludge level or slurry is here, here also we will have at the same level. The digester is conveniently built at or below ground level, comparatively cooler zone. See, if the maximum temperature to prevail is limited to 50 degrees Celsius, so we cannot keep it in a hot environment. So usually some part of the digester will be below the soil level, and for supplying biomass, the slurry inlet tank will be slurry inlet as well as the outer tank will be above the soil level. That we will keep it as above the ground level. So the remaining portion can be, it is better to keep inside the soil or below the ground level. The slurry, that is cattle dung and water in the ratio 1:1 for gobar gas plant, is fed from the inlet. So slurry is provided at the inlet tank. Finally, we will be collecting the biogas at the toppermost portion of the fixed dome through a particular pipe, and the remaining product after the reaction, the product that or the sludge will be collected at the outlet tank, which can be utilized as a fertilizer. Now coming to the next type, that is floating drum type digester. Here, instead of fixed drum, only difference is we will be providing a floating drum. You can see this one is the floating drum, and this can move over a central guide provided here. So it can move up and down over this central guide. Okay, so here the volume is not constant, but pressure is going to be constant. Always the pressure inside this chamber will be constant. In the earlier one, fixed dome type, the pressure will be increasing, but volume of the dome will be fixed one. But here volume is changing, but the pressure will remain constant. So it can accommodate more amount of methane or the biogas produced in this floating chambers compared to the other one. See, in the other case, once the maximum pressure limit is reached, we have to extract the gas. That is the only option. Here, if you can provide more float, then that means volume can be increased to a more value. That means more gas can be stored, and whenever it is required, we can utilize the gas. That is the advantage. The reaction, everything is same as the earlier one. See, here we will have the slurry inlet tank. Here we will be providing the slurry type biomass, which will be entering into the digestion chamber through a inlet pipe, and of course at the bottom portion only slurry will be entering. So in the upper portion we will have the biological reactions taking place. That is, bacterial action will be here in this region as a product. The biogas will be produced which will be stored in this vacant area. So once the pressure reaches the particular value, the float starts to move upward, so that the pressure inside this chamber is remain constant. So more quantity of methane can be stored. So of course the float will be moving over this central guide, okay, or the chamber will be moving over this central guide. So after the biological action, the sludge produced will be collecting at the outlet tank here. Okay, so here we will have a partition wall between these two, and over that partition, the central guide can move within this partition wall. So inside we will have a cavity like structure. So in that cavity, the central guide will be moving up and down, and of course at the topmost portion we will have a pipeline to collect the biogas produced. In this design, that is, pressure is constant. A dome made floats above the slurry in the digester. That is the only difference. The floating drum normally has a central guide which facilitates its vertical up and down movement. The gas generated in the slurry gets collected in the dome, and the dome arises. So here the area of the gas collection is, or the volume of the gas collection is not constant, as the dome can move. Based on that, area also, volume also increases. The weight of the floating steel cylinder ensures that the gas produced is under constant pressure, which gives this type of the digester its main advantage. See, how much pressure is to be maintained in this cylinder is decided by the weight of this cylindrical dome, okay, steel dome. Usually it will be steel structure. So the weight of that floating steel cylinder will decide how much pressure should be there inside this chamber. If the once the biogas produced pressure exceeds that pressure exerted by the weight of this steel cylinder towards downward, the pressure of the biogas will push it upward. So the motion of this cylinder or the dome upward motion of this dome is due to the pressure exerted by the biogas present inside this region. So the pressure is always kept as constant. Okay, that's all about the floating drum type biogas plant. Now coming to the comparison between fixed dome and floating drum. The digestion gas holder can be masonry on concrete structures. Since it is fixed, we can make it using either by bricks or concrete structures can be provided. But here, since it is floating, we cannot go for concrete structure or masonry. Instead, it is the digestion masonry gas holder can be mild steel or fiberglass, not fiberglass. So the dome will be usually made of mild steel or fiberglass in the floating drum type. Requires high masonry skill. The construction is very difficult. Only experts can do this one. Low masonry skill is required. Here, the skill required is much less for the fabrication. Low reliability due to high construction failure, and higher here. If construction failure occurs, we cannot depend on it one, and so that's why it is not reliable. And but here it is more reliable compared to this one. Variable gas pressure. Here the pressure inside the dome is constant. Here the pressure will be varying. Of course, compare if you talk about the volume. Here the volume is constant. In the floating type, volume is varying. That also we can say. The digester could be inside the ground. Here requires space above the ground for 3 tanks inlet, digester outlet. So see here all the 3 tanks are here all the 3 tanks should be kept above the ground level. That is the another difference between other case. Only inlet tank and this outlet tank is to be kept outside the ground level. But here all the 3 tanks is to be kept outside. That is the main difference between these two. So with this all biomass conversion processes are over. In the next presentation we will be discussing about the economics of biomass fuel production. Okay, thank you.